A large die casting machine is used to make automobile engine blocks. Is purchased for $4.3 million. For tax purposes, the value of the machine can be depreciated by 4.7% of its current value each year. What is the value of the machine after 15 years? And after how many years is the value of the machine 10% of its original value? Okay, so I've written down the exponential equation that we're going to use here. Y of t equals y sub 0 times e to the negative kt. Now, y sub 0 is equal to the original amount. So in this case, the original amount would be 4.3 million. But we're not going to use that quite yet. And then, of course, t is equal to time. And k is something that changes depending on your problem. K is what we're going to have to figure out first in this problem. Okay, so we want to figure out what the k is right here. In order to do that, what I'm going to do is I'm going to plug in into this t equals 1 into this right here. Okay, so that will give me y of 1 is equal to y sub 0 e to the negative k. Okay, now the t is gone because it's just a 1, so it got multiplied by the k. Okay, now we know that this thing depreciates at 4.7% of its current value each year. Okay, so I can use that information to say, okay, well, if it's 100% of its original value, okay, so you've got 100% of its original value, in 1 year, every year it depreciates by 4.7%. So in 1 year, we can subtract off 4.7% to get how much of its original value it is after 1 year. Of course, that we want to do that as a decimal, right? So 1 for 100% minus 0.047, okay? And that's going to give us 0.953. Okay? So what does that do for us? Well, that tells us that this right here, y sub 1, is the same thing as 0.953 times the original amount. Okay, it depreciated by 4.7%. Remember, y sub 0 is the original amount. So after 1 year, it's worth 0.953 times the original amount. Okay, the other side, I'm just going to write it how it was already. Okay. Now, the next thing that you should notice is that there's a y sub 0 now on each side because I substituted in place of this and used this y sub 0 to replace this y of 1. Okay, I can divide both sides by this y sub 0 and it's going to go away. Okay, so I would get 0.953 equals e to the negative k. Remember, we're trying to find out what this k is, and we're really close to finding it. Now, in order to get rid of the e, I need to apply a natural logarithm to both sides. ln of 0.953 equals ln of e to the negative k. Now, what happens when you take the natural logarithm of the natural exponential function is that those two things cancel out, and you're left with a negative k. So you get ln of 0.953 equals negative k. If you divide by that negative, or multiply by a negative, however you want to look at it, divide by negative 1, divide by negative 1, that'll give you negative ln of 0.953 equals k. Okay, now you can type that into the calculator on your own. I have the value here already, so we're going to round to 4 decimal places. So I get k is equal to 0.0481. Okay, so that's my k value. Okay, so how did that help us figure out what the value of the machine is after 15 years? Well, it helped us because we can now plug k into this original function up here. And we can also plug in the original amount and plug in a 15 for the year. Okay, so remember that formula is right there. Okay, so first of all, I'll write the formula using the correct value of k. So y of t is equal to y sub 0 times e to the negative 0.0481 t. Now, this is a tricky part for some people because they think that, well, the k is not negative. Why'd you write a negative there? Well, the negative's in the formula, okay? So the k is a positive k, but the formula is negative, okay? So it stays. And if we got an answer that was negative for k, then the negative on the k and the negative in the formula would have canceled out, and it would have been positive. But as it is, this is your function, okay? Now, to figure out what the value is after 15 years, I simply put in a 15 here. Okay, and we know that y sub 0 is the original amount, so that's 4.3. We're going to do this in terms of millions. 4.3 million. Okay, and then times e to the negative 0.0481 times 15. That's where the 15 is going in place of time. Okay, now if you stick that into your calculator, you'll get an answer that's about 2.09, and that's $1 million. Okay, so that will be the value of this machine after it's depreciated for 15 years. Okay, let's look at the next question. The next question says, after how many years is the value of the machine 10% of its original amount? Okay, so in order to do that, again, we're going to go back to this one here, but we have the correct k, so let me write that right here real quick. It's not on this paper. It's going to be y sub 0 times e to the negative 0.0481 t. Okay, so 10% of the original value. The original value, or the original amount, is y sub 0, right? Okay, so I can replace this side of the function with 10% of the original value, meaning if I put that as a decimal, it would be 0.10, 10% of the original value, which is y sub 0, equals y sub 0 again, e to the negative 0.0481 t. Now, as you can see, the y sub 0s, you can divide them again, so it doesn't really matter what that value was, what the original value was, in order to find out this question, okay? Because that original amount is going to cancel out anyways when we divide it on both sides. So you get 0.10 or 0.1, I'll keep it as a 10, doesn't really matter, equals e to the negative 0.0481 t. This time, it says how many years, after how many years, we're looking for the t. We're looking for this right here. Okay, but the process is going to be very similar to what we did on the first part of this problem. We're going to take the natural logarithm on both sides. So ln of 0.10 equals ln of e to the negative 0.0481 t. Whoops, parentheses goes all the way. Okay, so again, the natural logarithm with the e is going to cancel out. So we get ln of 0.10 equals negative 0.0481 t. Okay, we divide both sides by negative 0.0481. Okay, and that will give us our t value. Put that into your calculator, and you'll get t is approximately 47.9, and that's in terms of years. And that is how many years it would take for the machine to have a value that's only 10% of its original value.